In this video we're looking at transverse versus longitudinal waves. So for instance, we're just going to consider a sort of a sine curve as a representation of the wave. When you're dealing with say a skipping rope, start off with a skipping rope. There's a skipping rope hanging in place there. We should put it on the ground in reality, but you can take your skipping rope and kind of flick it side to side from one end, and you'll form waves to go over the top of that. Now, if we're considering the sine curve, the movement of the skipping rope to form the sine curve is side to side, and there's kind of a position in the middle that we might call an equilibrium or a static position, and the rope is moving either side of that. And this point it's going down, and this point it's going up, and this point it's going, and it shifts from side to side continually as the wave passes through the rope. In this case, this one here, this is what we would call a transverse wave. Transverse. Transverse is sort of like sideways, if you like. That's one way to think about it. And the opposite of transverse, when you're considering waves, is longitudinal. And longitudinal waves would be something like a slinky, where you've got all the springs, and you push and you get like a little pulse passing down the length of the wave. So one way you might represent that is this is the position of the slinky when it's at rest, of the coils in the slinky of the spring. But when you flick it, you're going to compress a whole bunch of them together, and then you're going to stretch a whole bunch of them out, and then as the wave passes down, you'd see it at a single point in time with a whole bunch of those compressions and stretched bits. The compressions we call compressions, and the stretched parts, where it's longer, we call rarefactions. Rarefactions. So the compressions and rarefactions correspond to these shifts in amplitude, positive and negative, away from the equilibrium positions for a transverse wave. Okay, so a compression would be the movement in one positive direction of the waves, and the rarefaction would be the negative direction of the wave. Yeah. It may not, strictly speaking, be correct, because if you consider a single just a single slinky coil, it's just moving back and forward, side to side, and it's really you're concerned with the position of that one single coil. So that one there might correspond to a single position here, and as the wave passes, it moves up to a peak, and then it'll go back in the other direction to a peak in that direction. So it's not so much about the I guess the actual spreading and the actual compression, as it is about the position of individual particles. Now, another way to look at this, which is also very useful, is to consider the direction of movement of the particles. So in this case, the direction of move of the particles in relation to the wave propagation. So when we're talking about propagation, that's the direction that the wave is traveling. Because remember, waves carry energy, and that energy propagates along with the wave, moves along with the wave. Energy is transferred in the direction that the wave propagates, and yeah, you get the idea. And with a transverse wave, the movement of the medium is perpendicular, that is at right angles, to the direction of propagation. So the medium, remember, the medium is the thing that the wave travels in. That could be sound waves in the air, it could be water waves in water, it could be sound waves in another medium, like some sort of metallic thing that you bang. and it travels. It could be this rope, could be the medium for our skipping rope. But in any case, transverse waves, the direction of wave propagation is perpendicular to the medium. Longitudinal, the wave's still propagating in the same direction, but this time the medium is moving backwards and forth parallel. So this time it's parallel movement of medium to the direction of propagation. Okay, so that's a very good way to compare and contrast them. They're both propagating in the same direction, but longitudinal waves, the medium moves parallel to the propagation, whereas the transverse wave, the medium moves perpendicular to the propagation.